Hello everyone. Today we are going to summarize the different types of numbers and arithmetic on numbers we have covered so far. Started from something called multitude or multitudes. So it is something which you get as a result of counting, when you are counting objects. So a multitude has two parts. It has a count and it has a denomination. An example of that is that if you are counting apples, so you can say I have 3 apples. So apples is the denomination, count is 3. And you can imagine other examples. This was our starting point in the first few videos. Later on, we expanded this idea further by introducing comparisons. So if you want to if you want to compare two multitudes, so comparison of multitudes. And one of the ways to compare two multitudes is through subtraction. When you subtract. And this gave rise to differences. So the result of a subtraction is a difference. Now a difference, we found out, can be positive or negative or 0. So you see, so the concept of 0 and the concept of negative arises naturally when you try to compare two multitudes by subtraction, when you view something as a difference. So, and that's why we say that, okay, we not only have counts, which are positive numbers, we also have negative numbers, and that's why the set of numbers was expanded to integers. Integers have positive numbers as well as negative numbers, as well as 0. But they're still whole numbers. They're still whole numbers. And another arithmetic operation which arises naturally when dealing with multitudes is that when you are dealing with pairs of magnitudes, pairs of magnitudes. So you take an apple and you take an orange, or you take a group of apples and a group of oranges, and this gave rise to multiplication. You have one multitude multiplied by another multitude. So you see, multiplication arises naturally when you try to pair things up. And of course, you can have multiple groups. So this times this, and so on. And the last arithmetic operation dealing with multitudes, so far we are doing everything with multitudes, was another kind of comparison where instead of comparing two things with their difference, you compare things by a ratio, you see. So division also arises as an arithmetic operation which is undoing multiplication. You see, just like subtraction will undo addition, you see, I forgot to mention that we also had addition. Whenever you combine different things, you have addition. So division is an operation which undoes multiplication. And if you use division as a means to compare two things, this gave rise to ratios. Yeah, we have one multitude divided by another multitudes. And in another interpretation, you can also view this as a fraction. So you can see that we are complicating things, we are adding, we are subtracting, we are multiplying, we are dividing, but throughout all these operations we are dealing with multitudes. The starting point is multitude. You have a ratio of two multitudes. Yeah, you have a fraction of two multitudes. So today I want to leave this discussion for a while and point you towards another important context in which these numbers will help you, which is different from multitude, and you will come across, is called a magnitude. And if you want to know the real difference between the two, let me just write down the operation. So a multitude is a result of counting. Whenever you are counting objects, the result will be a multitude. And this is a result of measuring. Yeah, measurement. Of course, this is more complicated because there are phenomena which cannot be dealt with simply by counting because there are no objects to count. So examples of magnitude will be, for example, length. Yeah, you want to know how long this marker is. Yeah? Or area. Yeah. For example, if I want to know how large is this board. Yeah. If I want to know how much can I write, so it's not just the length, but also the height. Yeah. So the area is kind of a measure of the size. And there are other things, for example, mass. Yeah. So when you want to measure these quantities, you have to agree on a standard magnitude. So let's say you want to compare, let's say this is an object and you want to find its length. Let's call it length. And you have a standard object. Let's say this is a standard object and you know its length. So let's call this L0 for standard and let's call this simply L. And I just want to compare these two. And I want to compare this through division. So if you can recall from our previous lectures, I simply have a ratio of this length to this length. Yeah. At this point I don't have numbers attached to it. I just have a physical object. Yeah. And I just say, okay, this will have a certain length which I want to know. And I have a standard. Yeah. This standard will be called a unit. This standard will be called a unit length. So I say, okay, I just want to compare this actual length with the unit or the standard length. Because they both have the same nature, they are both lengths. So this ratio will simply be a number. So if that number comes out, for example, to be 3, then you can say that, okay, my length is 3 units. Yeah? So how will I report this? I will report this, that the length L is 3 units, and the units here is L0. Yeah? So you see, recall how we reported a multitude. We had a count or a number, followed by a denomination. With the magnitude, if you want to report a magnitude will have a number just like this 3 followed by a unit. So this unit is basically, so this is what I mean by a magnitude. This will be an example of a magnitude, and because this is just a pure number is not a magnitude. This unit is also a magnitude, but this is a standard, that is kind of a standard magnitude. So this is a standard magnitude. So all the measurements of length, so let me give you other examples. For example, if you have 1/3 kilogram, you see a number followed by kilogram, and that kilogram is a special magnitude, a unit of mass. So this is your mass, volume, mass, density, different kinds of magnitudes you can measure. So you can see that although the discussion changed drastically from multitude to magnitude, but you're using the same numbers. You cannot do these calculations without numbers. Numbers will enter. So previously, so if I now remove this, and just here I write one example of a magnitude, so I will say, okay, 3 apples. Another examples could be 1/3 of an apple, of course, and similar, and so on. Here, for measuring, I can say 3 meters. Now, meters is not a count. It's not a denomination. It is not an object. You cannot show me a meter. A meter is a property of something. So, for example, just to give you an example, let's say this is a marker. So I can have 3 markers, but if I want to know how long is this marker, now it's the same marker, it will have property. A property 3 meters or 3 centimeters. But the same marker can have another property. I can try to find its weight. So maybe I can say, okay, it has, let's say, 1/5 of a kilogram. You see, the physical object is the same marker. So the difference between multitude and magnitude is that multitude deals with objects and it counts them. And magnitude is about properties. It's not counting objects, it's measuring properties of objects. So even for the same object, you can have multiple magnitudes. I think that should be enough. In the next lecture, I'd like to take this idea even further towards something we call a number line. So wait for that, and bye for now.